Yo hackers, welcome to a new video on the anti-VM techniques, right? So in this video we'll have a look at some of the common anti-virtual machine techniques that's been used by malware and also by adversaries, right? So yeah, let's get started. And it's been a long time, right, since we met on YouTube, right? And I guess it's the last month, I mean probably the last time which I uploaded video in YouTube was like back in May, I guess, of 2025. But no problem, we'll continue our journey from now. Okay. In the upcoming videos, definitely we'll have a look at some of the common and sophisticated EDR evasion techniques and also red team contents, right? So let's get started. So first, before getting into the the virtual machine techniques, first we'll have a look at what is anti-analysis, right? So anti-analysis, generally if you people, if you ever kind of analyze a particular malware, right? In the modern day malware, in the modern day scenario, most of the malwares they would be, having or utilizing a technique, something known as anti-analysis, right? So these techniques are it's kind of a set of techniques, right? That's been used by the malware, okay, to kind of lure or to kind of the hinder the analysis that's been made by the malware analyst or any sort of reverse engineer, right? So like what's the need for this, by the way, right? So let's say if you're creating a malware and everything is open, in or to be precise, like everything is kind of in plain text, right? Let's say what are the keys being used to kind of encrypt something, right, etc and etc in a malware's code, right? So at the time a malware analyst can kind of easily write detection rule and can easily catch the malware, right? So that's the reason generally malware authors or adversaries, they kind of bring up with new techniques, something known as the anti-analysis, right? And again, we're looking at the goals of anti-analysis, right? First, as what I said, that avoid detection by antivirus and sandboxes, right? So generally generally your sandboxes, right, or your virtual machines, or like your antiviruses, right, they used to kind of scan your malicious file, right? But if you're using some sort of anti-analysis that can actually throw out the analysis that's been made by the the security solutions, right? So that's one point. And the second, as what I said, is to prevent or to hinder the analyst, right, especially prevent reverse engineering, right? So reverse engineering, of course, is a crucial part in malware analysis, especially while performing malware reverse engineering, right? So yeah. And the third part is like delay or confusion analyst, okay, we'll have a look at it in the later part of the video, right? And the fourth part is like hide malicious behavior, okay. And in the last part, as you can see, who uses this, as what I said, malware authors, or even like apart from the malware authors, there are like even a lot of even games or software applications that been protected by anti-analysis techniques, right? As any adversary or any even a normal reverse engineer, okay, doesn't have the ability to kind of easily understand their code, etc, right? So that's the reason even commercial softwares were kind of secured with anti-analysis. And then we have the intellectual property theft protection tools, right? They also utilize the anti-analysis part. And here we have some of the categories of anti-analysis. As what I said, it's kind of a cluster of techniques, right? So anti-analysis techniques are kind of commonly grouped into anti-debugging, disassembly, and anti-VM, right? Apart from this, there are also many other techniques being present, like anti-emulation, right, etc and etc. We'll kind of cover each of this. I think I have already covered anti-debugging in the previous video, okay, but in the upcoming videos definitely we'll have a look at the anti-disassembly and the other sophisticated techniques, right? So in case of anti-debugging, as if you're using a debugger to kind of analyze a particular malware, especially while performing dynamic and advanced dynamic malware analysis, at the time to hinder or to kind of lure the particular analyst, okay, or to kind of stop the analyst from analyzing your malware. At the time, the anti-debugging techniques can be used. And while talking about anti-disassembly, let's say you're disassembling your particular malware into any sort of disassembler, for example ida or binary ninja, etc, okay. So at that time, to kind of make the disassembly part more hard, or more hard to kind of understand the the flow of execution, at that time the anti-disassembly techniques can be used, right? There are like many numerous techniques or plethora of techniques that's been available. For example, linear disassembly, etc, like, etc and etc, okay. We'll have a look at anti-disassembly in a separate part. Then we have the anti-VM, which we are going to cover in this video, okay. I'm not I'm not here to cover almost all the technique, but yeah, some of the techniques, okay, that's been widely used and popularized, right? So again, like what are anti-VM techniques, right? So if you people have experience in analyzing malware. Generally you people is to you won't analyze the malware into your main system or into your primary operating system, right? So generally you will install a virtual machine, or to be precise, a sandbox, okay, in terms of malware analysis. Okay, you will install a sandbox, and in that sandbox you will perform your analysis, right? And that sandbox is of course a virtual machine, right? So now let's say that I am kind of a malware no, a malware author, right? And now I'm actually writing a malware. Okay, and if I'm already having an idea of like what malware analysis is and how a malware analyst can actually analyze my malware, right? So at that time, with keeping the detections in mind, definitely I know that my malware would be kind of analyzed into a virtual machine or a sandbox, right? So now I need to think, okay, like how to if my malware is kind of analyzed within a virtual machine or a sandbox, how can I detect that, or how can I change the flow of execution? Okay, so this is where the anti-virtual machine techniques comes into play, right? And some of the common sandbox virtual machines like software that are like primarily used, right? Not sandbox but virtual machine softwares, I would say, are VMware, VirtualBox, Hyper-V, right? And we're talking about sandbox, we have many. We have the Cuckoo sandbox, we have the any.run, etc., etc., right? And why detect virtual machines, right? And as what I say, that even like most of the blue teams, right, especially if you want to analyze a malware, they will of course utilize a particular sandbox or a virtual machine to analyze your malware, right? The reason it's like really simple. If you're kind of executing the malware into your primary operating system, right, or your primary host, to be precise, at that time it can actually crash your entire system. It can lock down your system. Let's say if you're analyzing a ransomware, it can encrypt all of your files, right? So that's the reason you need a sandbox or a virtual machine, right, to kind of analyze with keeping the safe things in mind. And as what I said, sandbox, you should rely on visualization, as what I said. Like if you want to analyze a malware, right, of course you need a virtual box, I'm sorry, a virtual machine. Okay, and that virtual machine of course can be termed as sandbox in terms of malware analysis, right? And while talking about the let's say that if you kind of your malware actually detected that it is running within a virtual machine, okay, so some of the techniques that the malware can actually utilize is like exit immediately. Okay, let's say that I've kind of sensed that I am my malware is actually into a virtual machine. So by just recognizing that, okay, it can exit immediately. Okay, and the second part, which most of the people usually, or most of the malware authors usually use, is like execute the Bengen behavior only, right? So let's say I have a malware which have two personalities. Okay, one is the malicious one, and the second one is the actual it might be a normal execution, like just like kind of printing a message box, right? So now let's say I know my malware is actually analyzed into a virtual machine, and okay, let's call it call it a sandbox. Okay, into a sandbox. And if my malware detects that it is actually into a sandbox, at that time what it will do, it will actually change its behavior. Okay, it will change its behavior to kind of print a message box instead of showcasing its malicious intent, right? So with this again, to kind of confuse the analyst, like what's the actual the core concept, or the core part of malware is, like what it is trying to do. Okay, it's really tough to analyze at that particular part, right? And here are like some of the well-known malwares that's been utilizing the anti-VM techniques. Okay, and especially in the modern day modern day cyberspace, like almost all of the modern day advanced malwares, they have been using this technique. Some of the examples are, we have the Zeus bot, the trick bot, the emotet, right? The the Ryuk ransomware, and also the Locky ransomware, right, etc., and etc. So here are some of the common anti-virtual machine techniques. Okay, the first is about the hardware based, right? And we are going to enumerate something, we are going to focus on something known as the CPU and the instruction checks, right? So generally there are like many instructions, right? If you people have some experience in reverse engineering, right, or even like in terms of normal reverse engineering, or even in terms of malware reverse engineering, right? So generally there are like many instructions that's been focused on virtualization, right, itself, right? So and one of the instruction is something known as CPUID, right? So with this instruction, okay, so if you're using CPUID into your into into any of your program, okay, let's say even a hello world program, okay, at that time generally what happens, the CPI the CPUID, how it works, that this particular instruction is used to check that whether you're actually into a virtual machine, right, or like into a normal OS or a normal operating system or a normal host, I would say, right. So the reason is very sim the flow is very simple. Like generally we have the they register something known as ECX or RCX, right. So which is like generally used for counter purposes. Okay. um, what happens here, okay, that we have the RCX and ECX. Okay, if the 31st bit, generally it would be 32 bits, okay, and 64 bits in general. Okay, while talking about the size of the registers in 32 bit and 64 bit systems. Okay, so even like if you are into the 64-bit machine, okay, and if you're using RCX, of course the lower 32 bit is of course ECX, right. So within that ECX, we have 32 bits, I would say. Okay, 0 to 30, 0 to 31st, right. And the 31st bit, okay, if that is 1, which means we are into an hypervisor, or to be precise, we're into a sandbox, or a virtual machine, right. So generally CPUID instruction can actually be used to kind of query the processor, that what particular processor is this. Okay, and like kind of it's used to kind of check, okay, kind of an OGO host, or it's kind of a virtual machine, right. And the second part is like checking the CPU vendor strings. Okay, so generally if you're kind of analyzing a particular sample, right, um, not kind of sample. Okay, let's say if you're actually analyzing into any sort of virtual sandbox software, for example VMware. Okay, VMware, of course VMware would be utilizing its string VMware into various places, right. So you can use your malware, right, to kind of look for particular strings. Okay, for example VMware or VBox, etc., right. And the other thing is like hardware identifiers. Okay, we have the MAC address prefixes. Okay, so generally VirtualBox or VMware, they would be having a different MAC address a format, no, not kind of format, a different MAC address as compared to the the normal operating system, right. So that's one of the indicators. The second is the disk drive names, right. So generally if you're into a virtual machines, you would be receiving a lot of drive names, especially starting with VBox and VMware. So that's another part. And the BIOS vendor strings. Okay, so generally BIOS like generally focused on your manufacturer, might be a Dell, etc., and all. So let's say if your BIOS vendor strings having might be your virtualization software name, at that time it can also be another indicator, right. So now the second part is focusing on software based detections. Okay, so we have the process and driver detection. So this is like one of the easier one, I would say. Okay, so for example the tools, looking or enumerating the tools, right. So let's say if you have installed a new virtual machine, right, let's say a Windows 10. Okay, now we know to use a lot of features of either virtual machine, VMware or VirtualBox. At the time you need to install something known as the virtual tools. Yeah, so that will install a lot of tools, right, for kind of better features, I would say. For example, drag and the drag and drop functionalities and all, right. So at that time we can actually write a script, not kind of script, we can actually make a malware to enumerate that whether these particular processes are being present. Okay, we can enumerate the services, we can enumerate the processes being running in the system. And if it detects, if it matches the strings, okay, let's say a very simple if condition is enough. Okay, let's say if this particular VM tools ist.exe, okay, if it matches upon the enumeration of processes, at that time we can just conclude that we are actually into a virtual machine, right. So similarly for for the virtual box and also for the Hyper-V drivers, right, we can also enumerate drivers. Okay, and the other part is the registry checks. Okay, Windows based deduction. Okay, so if you kind of install any sort of virtual machine even in a host OS. Okay, most of the time it will, there is a chance that no, not kind of a chance, but there would be some sort of registry keys being created for specific virtualization software. It may be VMware or VirtualBox, right. And similarly, if you are into a virtual machine, definitely there will be registry hives focused on this particular virtualization softwares or sandbox softwares itself, right. So you can also make a note of that. And also as what I said, the installed guest additions. Okay, so that's also like one of the other indicators. And the third part we are going to have a look at is the timings and behavior. Okay, so generally if let's take an example of any of the common sandbox. Generally a sandbox would be slow. Okay, it can be just kind of with 2 gigs of RAM, okay, with a minimalistic amount of storage, right? And let's say a very simple calculation that if your malware is within an enterprise environment or an into one of the system in the enterprise, of course it would be a high end system. At the end of the day, it might be like having 8 gigs or 16 gigs of RAM, okay. But if it is kind of into a kind of a 2 GB or 4 GB of RAM, then at that time we can just think, okay, like conclude, okay, like we are into a virtual machine or into a sandbox, right? So that's one thing. And again, like as what I said, it's measuring the instruction time, execution time, then detecting slower input output operations, right? So as you usually VMs are really slow, okay, even if you like kind of allocating equal amount of RAM, but a memory, but still it can be slow at like many points, okay. So with that we can also think, we can also conclude that it's kind of we are into a virtual machine, okay. And the resource checks, again, as what I say, like low RAM or CPU core count, right? And also the other part is like the unusual screen resolution. Generally sandboxes would be having a different resolution, screen resolution, as compared to our normal operations or normal system resolutions, right? So that's one other check here. And the environment checks, okay, the system uptime, okay. Generally sandboxes uptime are like really less, okay, as compared to normal systems. So that's another part. And the lack of user files or activity, right? So generally sandbox, as generally used for analyzing purposes, so there would be not much files being present, okay. That's one indicator. Another part is the activity. If like there is lesser activity as compared to a normal use kind of a normal use case or a normal use flow, at that time also we can make a conclusion that we are into kind of analyzed by a malware analyst into a sandbox, right? So yeah, and now a small demonstration here, okay. So I guess yeah, just a second guys, let me just open the Visual Studio here, okay. So we are going to have a look at two main examples here, okay. One is for the registry based detection, and the second one is for the services, right? So we'll start with the VBox enumerator, which is like generally focused on enumerating VBox based services, right? uh, you know so if you have a look at the code, let me just minimize this, okay. So it's at the start it's kind of opening and kind of a handle to the open SC manager, okay. Okay, and if we go here, it's kind of using something known as the enum service status, etc. I guess that's some sort of enumerations being going to happen. Then yeah, and the key part here is like this particular string, okay. If the VBox string is present, okay, which means that we are into a virtual machine, right? This like the first part of anti-analysis or the anti-VM technique, right? So if we are into a VM, it will kind of print that VM detected, right? And if we are not into VM, it will say no VM, haha, okay. So and it will just print a message box, okay. So why SC manager, right? So SC manager stands for service control manager, okay. This is like utilized for kind of control or manage all of the services being running within your operating system, right? So yeah, now what I'm going to do here, I guess I already have a program here, okay. So let me just run this cd vbox enumerator, okay. So it's debug, I guess, yeah. And here I guess, yeah, here is my binary to run. And if I run this, as you can see, no VM, okay. So now that's fine, but let me just turn on let me just open my virtual machine here, okay. And upon this, okay, after opening this, now if I run the same program again, okay, it's just VM detected, okay. Now how? No, this is where the question arises, okay. So let me open a tool, something known as the process hacker, okay. uh, so if you in the search processes, let's type vbox, okay. So as you can see, the string also being present here, okay. So our particular program, okay, it will kind of enumerate all the strings, okay, with the keyword vbox, and if it is present, it will kind of print that's a vbox like virtual machine detected, right? So that's the part of here. Okay, so if I close this, okay, if I close this, okay, yeah. So as you can see, if I close, I know after closing it, both both of the services or processes being vanished away, right? So if I run the same binary again, it will just say no VM. Okay, so this is how a small example, okay, like of how really the anti VM technique can be utilized by the malware. Of course, it not gonna print message box in the real world environment, and as what I said, it can change its flow of execution, right? It can just show up a legitimate one, right? So that's one example. Okay, and now let me just go back to, okay, and let me just go vbox is that's registry. Yeah, so now we are going to perform registry analysis. Okay, and if like any sort of string being present, it gonna say that we are into a virtual machine. Okay, okay, so yeah, let me just run this, and as you can see, VM detected, right? So now let me just open that, one second, let me just open that solution here, which is, yeah. So this is a very simple program. Okay, just know we are having a function as key exist. Okay, and it's like opening the registry. Okay, and these are the strings we are going to compare or look for, right? For example, if this particular registry key is present, okay, at the time we can conclude that no, we are into a virtual machine, right? So to check that, we can use the registry editor here. Okay, uh, okay, and let's just follow the path that's been mentioned here. Okay, just a second. So it's like in the software, okay, in the HKey local machine registry hive, and we have the software. And if we go to Oracle, we have the virtual box, right? So with this particular registry being present, we can just conclude that that we are into a virtual machine, right? So that's how basically with this we'd be able to conclude that that we are into a virtual machine, right? So that's how even the real life malware, or the real world malware utilizing this technique, right? So yeah, like these are like a kind of a tip of the iceberg. If you kind of deep dive into it, will be also you can also have a look at anti-emulation techniques, even like focusing on some other instruction. Okay, other instruction that have been like separately focused on virtualizations. Okay, even like the point is like even there are instructions which will only execute or only run if it is inside a virtual machine, right? Without that, if you run that in a normal environment, it won't run. That instruction will fail. Okay, we'll also have a look at it in the upcoming videos. Okay, so that's the part of how the anti malware analysis would basically work, right? I'm sorry, the anti VM would basically work, right? So that's fine. Now from a defender's perspective, okay, from a reverse engineering perspective, okay, so I have opened the same binary into binary ninja, okay, which is of course a disassembler. Okay, you can just choose the type of disassembly you want, and also the format in which you want. It might be hex, linear, or whatever you want. So I have just used the graph overview. Okay, so let's say if you are a malware analyst, and if you are performing let's say if the same sample is actually hand over to you, how would be able to analyze that, right? So if you just follow the flow, okay, you can just have a look at the strings, right? So as you can see that we have the vbox string, okay, being present as what you have see saw in that particular code, right? That would be looking for the vbox string. Okay, and there are a lot of operations being going on. Okay, okay, like the main thing which I want to say is it is not an analysis video. Okay, I'm just here to showcase that how you can actually perform kind of a quick analysis. Okay, so as you can see that after kind of all the enumeration being performed, we are calling the close service handle, right? And there is a compare operation being going on. Okay, and based upon the result, okay, it will be jumped to this particular location. Okay, and if in this particular branch holds like no VM, okay, and this particular branch focuses on the virtual machine detected, right? So the entire solution is actually focused on the compare instruction, I would say, right? So you can of course debug this particular binary, okay. You can also create a similar one. You can just debug the binary, and if possible you can also patch that, okay. That's up to you. Okay, this is not a video on patching, okay. Of course we'll kind of will make one in the upcoming days, okay. And yeah, similar to this we also have the registry based detection, and as you can see here also a lot of comparison being going. Okay, now please people don't ask me like what's going on, what's the exact operation, okay. There are a lot of assembly operation being going on. Of course, to read this and understand this you need to have a knowledge on reverse engineering as well, right? So again, like if you go to the bottom, okay, and the main thing is like I'm in both of the program, I like already into the main function, okay. That's the reason I'm directly able to disassemble this, okay. So even I would say that if you're disassembling this, please go directly get into the main function. But yeah, in a real world malware, getting finding the entry point or finding the main function, of course itself, it's kind of a huge task, right? So again, as you can see, there are a lot of test operations being carried out, right? And based upon that you'd be able to see that whether the VM, again the VM detected or no VM, haha, right? So yeah, and again like a comparison operation being going on, right? And based upon the result it will again like perform kind of a jump if equal, okay. And if zero, then this particular branch; if not, then this the VM directed, and the further the function prologue, I guess, okay. So yeah guys, so that's all for this video, okay. So yeah, I guess it's a long video, yeah. And I might be blabbering a lot, okay. The reason is because I'm a bit sleepy, okay. So we'll catch you on another video in the upcoming videos, okay. Definitely will, as what I said, we'll focus on malware development, ED derivation, and also red team operations, right? And also some advanced malware analysis stuff if possible, right? So yeah, we'll catch you on another video, okay. Until then, bye, take care.